All right, guys, I decided to create a little video here to help you with domain and range because I figured out that I have a feeling that you guys are struggling a little bit with domain and range, so I made this little video for you guys. This is going to correspond with worksheet number 1. I just want you to go back and make sure that you're doing it correctly. I'm going to right now do a question that is similar to number 19, similar to number 22, and to number 23. Hopefully, if you understand these examples I'm going to do on this video, you will be able to do questions number 19, 22, and 23. Now again, I'm not doing these questions, I'm doing examples that are similar to these questions right here, and you'll be able to go do it, okay? All right, so let's get started here. Here we go. I'm going to start with a question that is similar to number 19. If you take a look at number 19 on your worksheet, it looks just like that. I just moved my vertex to a different spot. So you'll be able to understand. So remember, whenever we talk about domain, so let me put a little note here. Whenever we talk about domain, we are talking about the x values. Okay, the input, the values that, the x values that are going to be part of my function, inputted in my function. What I like to do is highlight in red pen all the x values that corresponds to a y value in my function. So let's take a look at some obvious one. For example, this is a positive 1, positive 2, positive 3, positive 4, right here. Positive 4, and if I find the y value for positive 4, if I follow positive 4 all the way until I get to my graph, it does match with a y value. I meant to be negative 3. So as you see here, negative 3 and 4. So 4 comma negative 3. 4 for x, negative 3 for y. It does have, that happens to be the vertex or the starting point of my absolute value function here. So 4 for sure is a point on my graph. And if I go to the left of 4, I know that if I follow it, I will find a point on the graph. If I go to the left of 4, keep going, I will find a point in my graph. All of these values that are left of 4, to the left of number 4, are values that if I follow, if I trace up to the graph, it touches the graph. So this is a value, 1 comma something will be a point on my graph. And if I keep going forever and ever and ever until I get to, if I keep on highlighting, all the way to negative infinity, if I go up, I will find a point in my graph because this graph is indicating that it goes forever, right? So I know if I follow it, I'll find a point on my graph. So it looks like all of the values that are less than 4 is part of my graph. And how about to the right of 4? So if I highlight it above the 4, so let's go, if I'm 4.5 and I go down here, do I have a value on my graph? Yes. If I go higher, right here, do I have a value on my graph? Yes, we do. If I keep going higher and I follow all the way up to my graph, do I have a y value? Yes. So it looks like no matter how far I go in the x direction to positive infinity, I will find a value on the graph. So it looks like all of the x values is part of my graph. There is a corresponding y value for it. So it looks like my domain, the domain for this, for sure, is all of the x values. All of them. Doesn't matter if you have a positive x value or negative x value, you will find a corresponding y value for it. The way to show all real numbers is to use the symbol for all real numbers. It's a double-legged letter R, capital R. So that's how I show the domain. How about the range? Let's talk about the range. The range is the y values. Okay, the range is the y values. So now I'm not going to focus on the x-axis. Now I'm going to switch pen here. Now I'm going to focus on the y-axis. That's where I'm going to focus now, is the y values. I'm going to focus on the y-axis. Y-axis, if you keep going from 0 up, you will go to positive infinity. In the y-axis from 0 down, you will go to negative infinity. I want to see if this graph over here, this function, has a corresponding y value for every single x value. Well, let's think about it. If I do have a corresponding value of y to an x value, I will be touching the graph. So is -3 matches with the x value in the graph. So let's follow -3. Yep, it does match with 4. We decided that earlier on is our vertex of our absolute value here. It's really not called a vertex, it's called a starting point. So if I go below -3, if I go to the right or to the left, will I touch my function? Will I touch the graph? No. So it looks like the lowest value, the least y value that I will have a corresponding x value to will be -3. But if I go above -3 to a -2 here, and I follow to the right here, I will find a corresponding x value for it. If I go up above to a -1, if I follow it, I will have a corresponding x value for it. And it looks like if I keep on following this trail above the -3, if I keep following 0, 0, if I am at y equals 0 and I follow to the right, I will find a point on the graph. And if I just keep on going, every time I turn to the right, I will find a corresponding value on the graph. And if I go higher, even higher, all the way to positive infinity, if I go to the left, I will find the graph. If I go to the right, I will find the graph. So it looks like it's all of the y values that are greater than -3. How do we say that here for our range? So we're saying all the y values that are greater than -3. Do I include the -3? For sure, right? If you go and you find it's a closed point here on the graph, so to say that I am including, I have to put an equals under. So I have to make those decisions of do I include or not include it? Here on the domain, all of them are included, so I just say all of the real numbers, okay? So let's do it in both ways here, the domain and the range. Let's do it in both ways. Let's do it in inequality notation, what we just did over here, all real numbers and all the y values that are greater or equal to -3. Now let's switch this to interval notation, which is one of the students' favorite way to say all real numbers. If you look at your notes that I gave it to you in class, to say all real numbers, we use -infinity all the way to positive infinity. We do not put brackets on negative or positive infinity. We have to use parentheses. So these two things over here, these two symbols are saying the same thing. All real numbers, all of the x values on our graph, and this is saying from -infinity all the way to positive infinity, okay? Now, how do we say the range in interval notation? I want to say all the y values that are greater than -3. So from -3 all the way to the highest value, which if you look at the graph, where did we head toward? We head toward positive infinity. We never put brackets on positive infinity. We put parentheses. Did I include the -3? Yes, I did. And to show that in interval notation, we use a bracket. Okay? So you just have to remember these notes. To include something, we use brackets. That's to include something. If something is not included, we use parentheses. Not include a value, then to not include, we use parentheses. You just have to remember that for infinity, something that goes on forever, we never use brackets. Never, never, never. Okay? So I'm hoping you can look at this example for number 19 and you'll be able to do something, you're going to be able to do your homework for this example number 19. Okay? All right. Now let's do an example for number 22. Let me see if I can do something similar here to number 22. So this one will be similar to number 22 on your worksheet number 1. Okay? Go check to see if you did the domain and range correctly. All right, so here's my graph. Here's my y-axis. Here's my x-axis. I am going to do a graph. I'm going to go to -2. I'm going to go to +1. Here's +2. I'm going to create the graph of y equals +2. Okay, this function right here is y equals +2. It's a constant function. It goes on forever. Oh, I want to change. Let me see. Let me change and let me put an open circle here. Okay, at -1, -2, -3, -4, -5, -6. Okay, this goes on forever, but mine stops at -6. And let me go all the way to, let me put a closed circle. -1, 2, 3, sorry, +1, 2, 3, 4, 5, 6. All right, from 6 to 6. Just happened to be that way. All right, so I have an open circle and this one is closed, okay? It's kind of hard to tell, but this one is open at -6, but it's closed at +6. Okay, so let's highlight the domain. The domain are the x values. I'm going to use red pen for my x values. Okay, I am at -6, and I'm trying to get to the graph. We always try to get to the graph. At -6, if I follow up, I will touch the graph, but it has an open circle. This means not included. -6 is not included. Maybe -5.9999 is, but not -6. Okay? So if I go above -6, if I follow the trail, I will find a value that touches the graph. If I go higher to -3, if I follow the trail, I do touch the graph. And it looks like I will be touching the graph if I'm at 0 for x. If I go up, I do touch the graph. And I will be doing this all the way to a 6. If I go past 6 and I go up, the graph no longer exists. So let's go back to 6. If I go up, I do touch a graph. As a matter of fact, I touch the last point on the graph. And because it's closed, it means included. So I am including the 6, that means bracket, but I am not including the -6, that means parentheses, okay? So let's go ahead and create the domain. We're going to do it in inequality notation, and then we're going to do in interval notation. Let's see if we do it right here, okay? So the domain, D for domain, and then we're going to do R for range. The range is going to be the y values we're going to do in just a little bit, okay? So let's talk about the domain. It looks like it's all of the x values, that are less than 6, right here, less than 6, a 5, 4, a 3, a 2, a 1, a 0. But -6 is less than all of the x values. So it looks like the x values is between -6 and 6, right? Then we go back and say, I'm not including the -6, so I'm not going to put an equal under, but I am including the +6, so I will put an equal under. In inequality notation, that's how we show that something is included and not included. Does not equal, I don't want -6, but includes the 6, then I do want it. Okay? Now let's switch that same exact saying to interval notation. How do I say this in interval notation? It's easy. You always pick the end point. When you have 2 points like this, you always pick the 2 end points. It looks like from -6 to +6. From -6 to +6, all the x's in between. I am not going to include, so that means I use parentheses, not included. But I do include the 6, so I put a bracket. Okay? So this is showing the domain in interval notation from -6 to +6. Okay? Now let's talk about the range. Let me switch to black pen here. I only want to show the range. That means I only want the y values that touches the graph. If I'm down here, you have to go left or right to touch the graph, right? In the x value, we went up or down to touch the graph. If I'm down here, if I go anywhere here, left or right, I won't touch the graph. It looks like no matter what x value you picked, the only point you always get for y, the only value you always get for y is this positive 2. Let's think about for a minute. Negative 6 was matching with the 2. Negative 5 was matching with the 2. Negative 4 was matching with the 2. If I was to create a table here, guys, if I was to create a table of x, y's, I'm not going to count negative 6 because it's not included. But negative 5.999 forever, I would match with the 2. Negative 5, if I follow, it matches up with the 2. Negative, let me skip a few. Negative 1 would match up with the 2. It looks like the only value we're getting for y here forever, 6, matches up with the 2. Looks like it's going to be going forever and ever and ever here between negative 6 and 6 and only get a y of 2. So it looks like our range is y equals 2, which it happens to be our function. It's a constant function, okay? So that's how I know those are all the y values we're going to get. We're not going to get y equals 1 or y equals anything else, okay? To show that in interval notation, the range for that in interval notation is just saying, well, the only number you are going to get is number 2, okay? That's the only range you're going to get in the y value is number 2. So that is included. We don't use, because it's the only, they're all closed. You might say, oh, Ms. Myers, it's not closed here for negative 6, but it is for every other axis, and even negative 5.999, something really close. 2 is the only number you will get for the y value, okay? All right, so that is the question that is similar to number 22. Now, if you take this notes when you're watching this video, and if you want to take this notes that I just wrote here and then come by and ask me any questions, please do so, okay? All right, let's do our last one, which is number 23. I'm going to do a similar to number 23. I'm going to try to do a graph very similar to it, okay? Okay, so let's see here. I am going to put an open circle at negative 1, negative 2, positive 1, positive 2. I'm going to come right here and put an open circle. I'm going to make a nice little bump up here. Negative, positive 2, 3, 4, 5. And then I'm going to come down forever. Okay? We cannot draw it forever, but this arrow here is saying, hey, this graph is going forever and ever and ever and ever. Okay? All right. Domain. Domain, we're only going to focus on the x values because that's what the domain is. The range. The range are the y values. We will talk about that after we determine the domain. Okay, so let's go ahead and trace all the x values that if we follow up or down will touch a place on the graph. Okay, negative 2, if I go up, I found a place on the graph, but is not included. That's okay, it's still a place on the graph. So not include this negative 2 right here. But I still got to count it. I got to mention negative 2 was not included. If I go up to negative 1, if I go up, I do find a spot on my graph. And if I do that for 0, I go up, I do find a spot on my graph. 0 actually matches with a negative 5. I'm sorry, a positive 5. So from negative 2 all the way to a negative 1, if we go up, if I keep on going, let's go to positive 1. If I go up, I find a place on the graph. Perfect. Let's keep on going further. And here I do touch a place on the graph. How about past this? If I go here, I can't go up, I won't touch the graph, but if I come down, I will touch the graph. And as a matter of fact, if I keep on going forever and ever to positive infinity, and I come down because this graph goes forever, I will find a place on this graph, okay, because it goes on forever. So it looks like my domain, let's do it both ways, in inequality and in interval. Domain and range, domain and range. Pause this video and see if you can do this. See if you can do this. See if you can do the domain. See if you can do the range. And then compare to my work. Pause it and try to do it. Okay, so it looks like my domain is from -2 to positive infinity. We cannot put infinity, the infinity sign, on our domain in inequality. We can here. Infinity is okay here, but I cannot use it here. It's not elegant or correct to put it in inequality notation. So I can say all the x values that are greater than -2, because that's pretty much what he's saying here. All these x values are bigger than -2, so all of the x values that are greater than -2, and I already made myself a note so I don't forget, is not included, so I will not put an equal in there. Okay? How do I say that in interval notation? The lowest value is -2, and it looks like I'm heading toward positive infinity. I don't include it, that means is a parenthesis, so I'll put a parenthesis here. And this guy never, infinity never gets bracket, always get parenthesis. You cannot put a bracket to stop a number, a high number. You can always go forever, okay? All right, let's highlight the range. Let's highlight until we get the hang of it. After a while, you will never need to be highlighting your graph all over. It looks like I'm at 1 for y. If I go to the left or to the right, I will touch a place on the graph. So it looks like between 1 all the way up to a 5, I will touch a place on the graph, right? You go to the left or to the right, you will touch a place on the graph. But if I go higher than 5, there's no way, there's no more graph. So 5 is the highest point on my graph. So between 5, if I keep coming down, let me go to the left or to the right. If I go to the left, nothing. If I go to the right, I do touch a place on the graph. If I keep coming down, because this graph goes forever, I'll always find a place on the graph. So it looks like all the way to negative infinity here on the y values, I will touch a place on my graph. So how do I say this? All the y values that are less than 5. That's exactly what we're saying. So all the y values that are less than positive 5. Do I include it? Yes, there's no open circles here, so it is included. All the way to a positive 5, including the 5, okay? So all the y values that are less than 5, so 5 is my highest. So 5 is my highest value. And the lowest will be negative infinity. So we put a parenthesis because that's what infinities get. And because I included the 5, we need a bracket. And I hope you can understand there's always this details of paying attention to bracket and parenthesis, include, not include. And that's, you know, something you have to get used to, reading the graph over and over and over. Okay, I hope this helps. Take these notes and come and ask me for help either a little bit before school starts or right after so I can help you. Okay, thank you.